The concept of differential calculus is a concern about how one quantity changes in relation to another quantity. The definition of derivative can be approached in two different ways that are interpretation of tangent line and rate of change.
Okay, now for the techniques of differentiation. First, the sum and difference rule. The derivative of a sum or difference of function is the sum or difference of the derivative. If fs equal to x power of 2 plus sine x, then f prime x is 2x plus cos x. Simple rule, just differentiate each part separately.
The product rule is used to differentiate the product of two functions, and the formula is dy dx equal to uv prime plus vu prime. The quotient rule is used to differentiate a function that is division of two functions, and the formula is dy dx equal to vu prime minus uv prime over v squared. Do you guys know what is the Bini derivative?
Of course we know. Derivative is rate of change of function with respect to variable. Then what is the technique?
The technique is the sum and difference rule, the product rule, and the quotient rule. For question 2, I'm going to show you how to solve a calculus problem that involves finding the derivative dy dx for two different functions. We'll be using some important rules from differentiation such as the product rule, quotient rule, and derivative of standard function like ln x, e power x, and trigonometric function. Question A. The first function is y equal to ln 3x squared multiplied by secant squared x plus 2. Since this is a product of two separate functions, we use the product rule. Product rule formula is dy dx equal to u prime v plus u v prime. After we get u and v, we should differentiate each one by one. To get a u prime, we should differentiate u. After differentiate u, we're going to have 2 over of x. After that, we should differentiate v to get a v prime. After differentiate v, we're going to have our v prime, which is 2 secant x plus 2 multiplied by 10x plus 2. Next, we should apply our product rule, which is we just fill in the formula and got the answer. The function for question B, y equal to e power of 4x plus 2 over cos x. In this question, we use the quotient rule formula and using the same step as the question A and fill in the formula and finally got the answer.
Okay, for the question 3, we need to find the derivative for this function using the chain rule. First, we need to recall the chain rule. It is dy dx equal to dy du multiplied by du dx. Second, you need to set ln 2x power of 2 plus 3e power of x plus cos 3x as u, so that our original function becomes y equal to u power of 5. Since y is equal to u power of 5, the derivative of u is dy du equal to 5u power of 4. Now, we need to differentiate u. Let's break it into 3 parts and do them one by one. Let's start with ln 2x power of 2. First, we need to differentiate ln. After we differentiate ln, we're gonna get 1 over 2x power of 2, and differentiate 2x power of 2 is 4x. After multiply it together, we got the derivative is 2 over x. Next, 3e power of x. This one is straightforward. The derivative of e power of x is still e power of x, and the constant 3 stays in front. That's how we got 3e power of x. Lastly, cos 3x. Okay, we need to differentiate cos, and we get negative sine 3x. And so we also multiply it by the derivative of 3x, which is 3. And the answer is negative 3 sine 3x. So after combining them, we got du dx is equals to 2 over s plus 3e power of x minus 3 sine 3x. Now for the full chain rule product is, we got dy dx equal to 5u power of 4 multiplied by 2 over x plus 3e power of x minus 3 sine 3x. And finally, substitute back u in dy dx, and that is our derivative. So now we move on to the next question.
For the question number 4, this solution use implicit differentiation to find dy dx for the equation y square ln 3x minus e power of 2x plus y minus tan 4y equals to 0. Here's my explanation each part step by step. Step number 1. You need to label and identify the function. The equation involves product and composition of function. Define parts of the expression to apply the product rule easily. We apply the product rule. The product rule formula is u prime v plus uv prime. We move to the step number 2, which is differentiate each term implicitly. Differentiate each term with respect to x, remembering that y is a function of x, so chain rule applies. Step number 3 is substitute derivative into the equation, combine and rearrange to isolate dy dx. Step number 4. Factor out dy dx. Move all term with dy dx to one side and factor. So we got 2y ln 3x minus e power of 2x plus y minus 4 secant square 4y dy dx equals to negative y square over x plus 2e power of 2x plus y. Step number 5, solve for dy dx. Finally, divide both sides. So the final answer is dy dx equals to negative y square over x plus 2e power of 2x plus y over 2y ln 3x minus 4 secant square for y.
Next, let's move to the last question, which is question 5. Step 1, you need to identify fs. So let fs equal to 4 root of s minus 2 over square root s. Step 2, find the derivative of fs. Using power rules and derivative, fs equal to x power of 1 over 4 minus 2 power of negative 1 over 2, and then differentiate f prime s equal to 1 over 4 x power of negative 3 over 4 plus x power of negative 3 over 2. Step 3, choose a value close to 80.99 for s0. So s0 equal to 81. Using formula delta s equal to s minus s0. So the answer is negative 0.01. Step 4, evaluate f s0 and f prime s0. First, substitute f which 81. The answer is 25 over 9. Then substitute f prime which 81. The answer is 31 over 2910. Last step, apply linear approximation using formula f s0 plus f prime s0 multiplying by delta s. So the answer is 2.778.
In conclusion, derivatives show how a function changes with respect to its variable. They help determine the slope of a graph and are used to solve problems involving motion, optimization, and change in fields like physics, economics, and engineering.